Have you ever stared at those cryptic lines of code that somehow magically automate tasks? Well, that's shell scripting, and it's about to become your secret weapon. In this video, I will take you from shell-shocked beginner to an automation wizard. When I first joined a DevOps team, I spent hours on doing repetitive tasks until a senior engineer showed me how to write my first shell script. So suddenly I was completing in seconds what used to take me half a day. And today I'm passing that same magic on to you. No computer science degree required. But before we dive into scripting, let's understand what we're actually talking about. What is shell? What is bash? And why do we even need shell scripting? What is its purpose? On your computer, you have a graphical user interface, or GUI, where you execute tasks by clicking around, creating folders, copying or moving files around, opening browser or other applications. So this visual layer that lets you interact with your computer. In parallel, you have what's called a command line interface, or CLI, where instead of clicking on stuff, you run commands that tell computer to create a folder, to copy or move a file, open an application, and so on. And CLI is much more powerful than GUI or GUI. And it's faster if you know what you're doing. For example, if you want to create 100 folders, you can create them all at once with one single command on CLI. While manually in GUI, you will have to create each folder one by one. So CLI is the approach of using typed commands rather than clicking icons in order to do stuff on your computer. And on Linux OS, the program to run and interpret these commands is called shell. And bash, which actually stands for Born Again Shell, is the most common implementation of shell program for Linux systems. So bash is just one brand or flavor of shell. Just like Chrome is just one implementation of a browser program. And note that bash is not exclusive for Linux. It can be used on other operating systems as well. But it is the most common one for Linux, for many Linux distributions. And bash is not just for running commands, it's actually a full programming language that lets you automate tasks that would otherwise be tedious and very time-consuming to do manually. And that's why people use shell scripting or bash scripting interchangeably. So this means that with bash, we can write automated programs to execute stuff on our computer. And those programs are called bash scripts. But note that bash specifically has more advanced features compared to some of the simpler flavors of shell, like sh, for example. So in this video, we're learning bash scripting specifically. Now, to put everything more in context, we also have what's called a terminal, which is basically a graphical window to type out your commands or run scripts that shell program or bash will execute. Now, if you want to learn basic Linux commands first, before we go and script them in a program, you can actually check out this video that I'm going to link on the top, then come back and continue with this video. So with that, we can dive right into bash scripting. But first, let's make sure that you have everything ready to get started. So if you already have Linux, then great, you're all set up. However, if you have Windows or Mac, how do you get a bash environment to practice bash scripting? Well, it's actually pretty easy. If you're on Mac, like me, you actually already have bash installed, but it's not the default. So open your terminal, and in order to switch to bash, simply type out bash in your terminal, and it will switch to bash. It's the same. The default, in my case, is Z shell, And now we switch to Bash. On Windows, you have several good options. And the best option is to install Windows Subsystem for Linux, or WSL. And WSL is actually superior to some of the alternatives because it is a more complete Linux environment and also is officially supported by Microsoft. And here you see the installation instructions on the screen. Now, everything you see in the video, installation guide, as well as all the commands and code snippets we're going to cover will all be linked and documented in a video handout that we created to make following this demo much easier for you. So this document will include all the commands and script that we will write in exactly the same order that I'm executing them here, with some additional explanations. So make sure to grab that from the video description so that you can follow easier, and let's dive in. So let's imagine a practical, real-world scenario. Let's say you are a DevOps engineer responsible for analyzing logs of certain programs to monitor those services and programs and see whether there are any problems or issues that these programs are logging and how to fix them. And let's say we have these two log files that we need to analyze: application.log and system.log file. And again, check the video handout to download both of these sample files. Once you've downloaded them, create logs folder in your current directory, whatever you're executing this from, and put those application and system log files in there. So in my case, I already have them in my logs folder, and here they are, application and system log files. So now, as a DevOps engineer, I want to check these logs and see if there are any issues that the programs are reporting and take any relevant action. So let's start executing commands to perform this task. So I'm going to switch to the logs folder, and I'm going to print out the entire application log file contents. And I see that there's some error, critical, fatal, and so on. So now I want to filter out and see all the error logs. So I'm going to filter the file contents just to show me the error messages. And here they are. I see that there are some issues with payment gateway, the database has issues, and insufficient disk space. So I see a bunch of information about what's going on in the system. I can also display how many error messages there are in an application log file using this parameter. So this is going to give me the count of error logs. And I can do the same for, let's say, fatal errors. So there are some issues going on here. And let's say I want to do the same for system log. I want to quickly check what's going on in the system log. There you go. We have some fatal errors. Let's check critical. And let's see what those critical errors are in the system log file. And there you go. And finally, let's say that this folder, this logs folder, includes tens of different log files, right? Lots of programs are outputting their logs in the same place. And my job is to check these logs every single day. And since my job is to check these logs every single day, I only want to check the log files that have changed or that have new entries within the last 24 hours so that I don't have to go through the whole thing again if nothing has changed in those program log files, right? So I'm going to execute a command that first checks which log files actually have new entries or have been updated in the last 24 hours. So I'm going to do find. So in this current directory, find all the files that end with .log and only give me the ones that have been updated in the previous day. So this option here basically filters files based on their modification time. And this value, or -1, means less than 1 day old. So any file that has been modified less than 24 hours ago. So -2 will be files that have been modified within the last 2 days. And if I execute this, and we get an issue because we need to enclose this in quotes, like this, so that this character gets interpreted as a regular expression. So any file that has whatever name and then ends with .log. So let's execute this, and you see, it found 2 files that have been modified within the last 24 hours, because I just put those files in the folder. So if you execute this in 3 days, for example, this will not be the case because the files will be old already. So now, as a DevOps engineer, I know which files have been modified since my last check, and I can only check and scan through those files. So this is what I need to do every day. So imagine doing this manually as part of my job. This would probably take around 30 to 45 minutes, depending on how many log files I have. And again, I have to do this on an almost daily basis. It sounds like a lot of tedious, repetitive work and pretty much a waste of DevOps engineer time, right? Which it is, because it requires repetitive command entry. So I need to execute the same commands to grep, to filter all the errors and manually go through them. It is time consuming. Even with just 2 or 3 services, you already typed multiple separate commands. You have no aggregate summary, so you have to go through each file separately and mentally track the overall outcome. And let's say you're interrupted halfway through with another task, you might lose track of what you've checked and so on. And this is just a very small, simple task. And there could be lots of such repetitive work as part of your DevOps engineer or software engineering role. But imagine instead if I could save these steps and commands and simply say, run all these commands in one go in this order. Well, that's a shell script. So let's create a file so we can take all these commands we executed manually one by one, put them all into a single file to have the logic defined once, and then we can execute that script or that file with one command every day without manually repeating the command execution or the logic. And this is exactly why shell scripting is so valuable for DevOps, because it automates a lot of repetitive tasks. Plus, it ensures consistency because the same script gets executed. You're not dependent on memorizing which commands to execute in which order. You can program in a proper error handling, and it also serves automatically as a documentation of the process. So let's build this step by step now by creating our first shell script or bash script. So a shell script is simply a text file with Linux commands. That's it. So let's create a file with a touch command, and let's call this file analyze logs.sh. And once we have that file, let's open it with vim or Vim editor, which is a terminal editor since we're practicing Linux commands here. And in Vim editor, you press I to go into insert mode. And I'm actually going to copy the commands that I executed before manually in the command line right into my script. So first, I'm going to run a command to find me only the log files that have been modified. Then I'm going to go through application and system log files specifically to show me all the error files, as well as how many error logs there are, how many fatal, and so on. And for now, these are hard-coded, so I'm checking explicitly for these files. We're going to take this logic and make it incrementally better in this video. So let's save this with escape and then colon WQ, write and quit. Now that we have this shell script, how do we execute it? Well, first we need to make this file executable. So right now, if I do analyze logs.sh, which is how you execute shell scripts, you see we get permission denied because this file is not executable, or it doesn't have execute permission defined. And what does executable mean? Well, other operating system programs like Python, even the Vim editor, all these Linux commands, these are actually all programs. So this is a program execution, this is a program execution. And they're also called executables because, like our custom script, they are just a list of Linux commands that someone wrote that can be run or executed on our OS. So to make our custom script executable, we just added execute permission using change mode plus execute command. And now we can execute it. And this here basically tells shell to look for the script in the current directory. So in this directory, there is a file called analyze logs.sh, and let's execute. And there you go. So first it printed out all the modified log files, then the error logs, then the number of error logs, and so on. So basically just executed all the commands one by one. Now, there is one thing I want to highlight here, because you may be asking, why do we have an sh extension at the end, even for a bash file or even for a bash script? And what if it was an sh or z shell script? How do we differentiate if they all have the same extension? Well, first of all, these extensions are not required for Unix or Linux systems to execute script files. So a shell script will run perfectly fine with no extension included if it has the executable permission. As I said, Vim, Touch, they're executables just like our custom file, right? They don't have sh extension. So the same way, if we remove this, it will run perfectly as long as we add the executable permission. So they're usually added as a convention because this makes it easy for us humans to identify any shell script files. It also makes it easier to recognize the script files in a directory listing, for example, when we list all the files inside. And it's basically just a visual cue about the file's purpose and execution method. Plus, if you open this in code editors or IDEs, they will usually recognize that it's a shell script because of the extension and give you the relevant syntax highlighting based on that. So that's the reason why we're adding here, but it's not required. And it also means that a script file, analyze logs.sh, could actually be a bash script, could be a z script, or script of any shell implementation, not just bash. Now, in that case, we have a follow-up question, which is, how does the interpreter know which shell program the script is written in when it executes? Was it written with bash syntax or with other implementation, which is a valid question, and that's where what's called a shebang statement comes in. So if we open our file again and go to insert mode with I, we have a statement called shebang that looks like this, which goes at the beginning of the script and it determines which interpreter should run this. For bash scripts, this will be bin bash, so that's where the bash program itself is located. So this line says that bash program should be used to execute this entire script if it's written in bash syntax, which is slightly different from other ones. This one will say that the interpreter should be POSIX shell script. So in our case, let's add bash here. So the system will know that bash interpreter should be used for executing the script. So as you see, a shell script is simply a text file with a bunch of commands, but with a special first line called a shebang that tells the system that this is a script and this interpreter should be used. Again, let's save it, and we can see that it works fine again. Great. Now we made script code easy to read. Let's print that out. So the script file itself is easy to read. We see what commands are executed. However, the output is not easy to read. Like we have a bunch of log files and we have some numbers. So we wouldn't know what these are without actually looking inside the script. Plus the lines are not separated and it's hard to see where each command execution and output starts and ends. So this is not really human readable. So instead, we want to see the output with information about what the output means, as well as separate each command output from each other, right? To make it cleaner, nicer for human review. So let's adjust our script to print out this information with echo command. So again, insert mode, and right here, I'm gonna print out some echo commands. I'm gonna say analyzing log files, and then we can do some kind of visual separation like this, some visual decorations. And here I'm gonna print out that this is a list of log files updated in the last 24 hours. Then here we can say searching error logs in application, log file, number of error logs found, and I'm going to copy the rest so that you don't have to watch me type this out. And there you go. We have added some information before each command output. So let's save this and execute. And there you go. Analyzing log files. And this is a list of files updated in last 24 hours. We're saying what this number represents and so on. Now, it has additional information, but it still can use some optimization like line breaks, for example, where one command execution ends and the other one starts. So let's add those in as well. We're going to add new lines in the echo command using \n. So this is going to be new line, but this is important for this new line character to be properly interpreted by the echo command. We need to add -e flag, which basically tells the echo command to interpret \escape sequence instead of treating it as a literal string. And we're going to do the same here before each line. And don't forget the -e. Okay, and there you go. Let's execute again. And we have a little bit cleaner output where we see the command executions separated for better readability. Great. Now, there is one important thing that we would need to optimize in this script file. So first of all, let's see which directory we are in currently. If I do ls, or we can also do pwd, which shows us the working directory that we are currently in. We're in a logs folder with a bunch of other log files, and that's where we created our script file. However, the script file can be in a separate location. Probably should not be in a logs directory, right? So let's say we move it out of the logs file in this directory, in my home directory, basically. And we can do that by using this command. So we move it from here to, I can just copy the absolute path. And now we can go out of the directory and we're going to have the analyze logs here. Now, what happens if I execute the analyze logs script? Well, when it gets to executing the commands for filtering application and system log file, error messages, it will not find those files. And the reason is because we have hard-coded their location. It will not be able to find application and system log files. And that's because we are looking for them in the current directory. So first, we're looking for all the log files in a user's home directory, which applies to many folders on my computer. And then we're looking for application and system log files in the same directory as the script file. But it makes the script very inflexible because if I move it around, it will break because of this. So to make our script file more robust and to make it able to execute from anywhere without breaking, we're going to do one very simple but very important change, which is we're going to add absolute path for the directories and files that we want to work with in the script. So first of all, we're going to say we want to find and analyze log files only in the logs directory, which is in /users/nana logs. So we're providing it the absolute path on the computer, and we only want to look into this folder, not any others in my home directory. And the same way, right here, we're going to provide absolute path, which is users nana logs. And we can just copy this. And now let's save. And if we try again, our script works. And now if we move it around and put it in whatever place on the computer, it will still work the same way because it knows exactly where to look from anywhere on the file system. Now we have written just a few lines of code. However, we can already start optimizing this to use the full power of scripting versus manual execution of commands. For example, if you look here, we are actually repeating the names of the files as well as directory location multiple times throughout the script. So now, for example, what happens if we change the location of the log files or we execute this on a different machine where the logs are located in a different directory? We would have to rewrite almost every single line of this script to make the change, right? Which is not very optimal, and it makes the script not reusable. And that's where the concept of variables come in. With variables, we can store the repeated values like the directory location, as well as file names, or even the error pattern. And these type of values that are repeated, we can store them once and reference them everywhere we need that value. And variables are a concept from programming, and it works the same way here in bash scripting. So let's make that optimization and introduce some variables. So we're gonna grab this value and create a variable called log directory. And that's gonna be the value. We are also repeating the application log file name. So we're gonna put that also into a variable. Now let's call this application log file, like this. And let's do the same for system log file. There you go. And now we can remove those hard-coded values and instead use variables. And the syntax for accessing variables in bash is $, and the variable name, like this. And we're going to do the same here. $, log directory. And we're going to enclose this in quotes. Because we also need this slash. So this is the log directory, and inside that we have the application log file. And this will now give us the absolute path of the log file. So we are reusing both variables here. And I'm just gonna copy this whole thing. Like this. And we're gonna do the same for system log file. And if I save this, and let's run it again, we should see the same output as before with just a more optimized script code. Now, if the log directory changes, or if we execute this script on a different machine, we can simply adjust this one value here, as well as the log file names, without having to rewrite every single line of code. And now we're going to take this script even further, adding more advanced logic so that we don't have to hard code the log file names and repeat the code for different error patterns. So we're going to make this code much more elegant and much more powerful in the next steps. However, to make working with the code easier, instead of using Vim without any syntax highlighting, we are actually going to switch to a Visual Studio Code so that we can edit the code much easier. Yeah, which means simply download Visual Studio Code if you don't have it, or use any other code editor, doesn't matter. We're going to open the file in VSC. And we immediately see the syntax highlighting for variables, variable usage, for the Linux commands, parameters, and so on. So we have extracted the file names and directory name into variables. Now we can do the same for the error patterns, because this is also something that we're repeating multiple times. And what if we want to extend it to other error types, repeating multiple times? However, for the error pattern, we actually have multiple values. So it could be error, it could be fatal, critical, it could be exception, and so on. So what if we want to have one variable that references all these options? For that, we're going to use what's called an array variable. So we have a variable that holds multiple values, like an array in programming languages. So we're going to call it error patterns. And by the way, in bash scripting, you're not allowed to have any spaces around the equal sign, like in other programming languages. So you actually have to write it like this. Just a small note on that. And the syntax for error variable is brackets. We just define the options inside. So we have error, fatal, and note that we don't have comma here. We just have space. And let's also add critical in there, like this. So now, in order to access each value from that array variable, we simply use index of the array. Again, a concept from programming. So this is how it's going to look like. We have $, and then we have curly braces, and we access the first element in that error variable using index 0. So this is how we extract values from an array or array variable. So this is going to give us the first element. I'm actually going to copy this. And now we need the second element, which is fatal. So we're going to use index of 1. And finally, critical is last element. And there you go. So now our Linux commands themselves do not have any hard-coded values, right? Everything is parameterized, and we're referencing them with variables. So again, if something changes, the values of this change, we simply adjust it here at the beginning, and the code stays unchanged. Now we can do one last thing with variables here, which is we can actually save the result of command execution also as a variable. So for example, this one here, this command returns a list of all the files, all the log files that have been modified in the last 24 hours. So we can save this list also as a variable by simply defining a variable, let's call it log files, and saving the results of command execution there using $sign and brackets. And this is a syntax for what's called command substitution. So whatever that command returns is referenced like this, with this syntax, $sign and brackets, and that captured value is then assigned to a variable. And we can then output that variable like this. And we can validate that everything is still working by executing the command. This is our updated command. There you go. Okay, now let's say we want to expand this script to analyze all the log files in the log directory, because maybe all other service logs are collected here as well. So we want to analyze them also, not just the application and system log files. And then for each log file in this folder, we want to check all the error patterns defined here. So for example, if we have 10 different log files in this logs directory, we want to go through each one of them and do the log analysis of every error pattern. Now, we could write this logic 10 times for each file, like we have done this here, but that would also mean that would be a lot of repetitive code, first of all. Plus, it would also mean that we would actually need to manually go and check all the files in the logs directory, or execute this find command, copy all the names of the log files, paste them into the script as file names, because we need to tell the script which files to actually scan, and that is definitely not feasible, especially for something that needs to be done every day, automatically. So instead, we want to have a dynamic logic without hard coding of any file names or values like this, to go through all the log files it detects by itself, one by one, and do the same analysis for each one. And that's exactly where the concept of loops come in. So we loop through and iterate through log files in the folder and execute the same logic for each iteration. So let's go ahead and do that. So let's optimize our code to make the logic much more dynamic using loops. So right here, we are already saving the list of log files that have been changed in the last 24 hours, right? So we have that value right here. So after that, we are gonna create a loop to go through these log files one by one and execute this scanning logic. So we're gonna say for log file in this log files array variable, and this is a syntax of loops in Bash. We have colon and then do. So do this logic, whatever is in here, for every file or every item in this log files array. And then we need to explicitly tell the program that the loop is now done using done command or done directive. So now let's see the logic here. We have hard-coded values, right? We're saying go through this file and that file. Well, that's irrelevant now because we're going through every file that the program detects automatically. That means we don't have to hard code any file names anymore. Instead, we're going to say check error patterns for error in whatever the program detects here. So it's going to find all the recently changed log files and it's just going to go through them one by one. So we don't know whether it's application log or any other one, but we want to print that out still. So here in the echo command, in this string, we are gonna print out which log file is analyzed for error in each iteration, like this. So we're not hard coding the log file, we are just accessing it dynamically from the loop. And then for that log file, we also want to print out the number of errors. Again, no hard coding, because it's going to be a dynamic value. So we're checking for error, fatal, and let's also check for critical. So number of critical logs in the current log file, and this is error pattern 2. And that's it. So all this logic here where we're repeating the same thing for system file, we don't need it anymore because this is already covered here. So this will execute the logic for application.log, system.log, and whatever other log file is in there. And that makes our code cleaner, more reusable without repeating the values, but also extending the logic for more values dynamically. And by the way, we can also avoid repeating the error pattern value since it's the same as this one. So I'm going to copy it and substitute it here as well. So we have the error. So this is error pattern 0. This is the fatal. This is the critical. And let's say we also want to print out these other types of errors also, not just the number or the count, but also the actual errors. So I'm going to copy this and paste it in here. We simply change the error pattern index, and there you go. So this will print out the error messages and the number of those error messages, or how many they are with the count. This will print out the fatal messages or the fatal logs right here, as well as the count of those fatal errors. And we can do the same here, where we print out the actual critical errors and then the count. So I'm going to save this. And let's go back to the terminal. Let's clean this up and let's execute it. And let's see. Let's actually make this smaller. So there you go. Searching error logs in system log file. That's the first one from the list. And it shows us all the error messages. We have 13 of them in total. Then it shows or prints out the fatal logs. We have 2 of them, and critical. And then it starts doing the same for the next file, which is application. And for application log, it prints out error, fatal, critical logs. So without rewriting the logic multiple times, we are applying it for multiple files dynamically using a loop. Now, you probably already saw that we have another opportunity for using loops because we're repeating the same logic for the error patterns, right? So these 2 sections of code are basically repeated 3 times for each error pattern, which is, again, a perfect use case for using loops, where the same logic needs to be applied to each element in a list. So that's going to be a loop within a loop, but will make our code much cleaner and optimized. So let's do that as well. So right here, we're going to create another loop for each pattern. So let's call it pattern. This is, by the way, variable name that we define ourselves for pattern in this error patterns variable. So we're saying in this array variable, in this list, we're going to call each item pattern, which is like a temporary variable. And for each item inside, we want to execute this logic. And again, we need to indent this whole thing. And at the end, we're going to say done. So the program knows where the loop starts and ends. So now let's look at our logic. Now instead of accessing the element like this, we actually have this element one by one in order as a single variable. So instead of array, we have a variable that has one value at a time. First error, then fatal, and so on. So searching whatever that pattern currently is. So error first in the log file that we are currently iterating through, and then execute grabbing or filtering that pattern in that log file. And the same here, we're going to say number of this pattern logs like this. And all this logic that we were repeating to access each element of the error patterns, we don't need anymore because the iteration will go through each element automatically one by one without us having to hard code it. And as you see, with loops and variables, we made our code much more flexible, much more extendable, and much cleaner. We literally just have 4 lines of code that runs logic on as many files and as many error patterns as you wish. Now there is one final thing we need to do before we execute this, and that is right here to extract individual values from an array. So if we execute this script now, let's actually see what happens. Again, let's clean it up. Analyze logs. And we're going to see that it does error scanning for system log. And let's go here. And then it does error scanning for application log. So basically, it only takes the first element of the array and it doesn't work for the other patterns. And that's because we need to use proper syntax to expand an array variable so that the program accesses all its elements as separate elements or separate entities. So expanding an array to its individual elements has a syntax which looks like this, which is actually similar syntax to how we get the individual values from the array variable. And then we use this element here, this character. And this is actually, it's an array subscript that translates to each element remains a separate entity in this array. So it's treated as individual entity or item that gets assigned to this pattern variable. So just a syntax detail here for how to iterate through arrays or array variables versus a list of log files. And there are different subscripts or array subscripts. For example, with star character, it would go and combine all these elements as one single string. So there are different subscripts that you can execute on an array. This is what we need in order to get individual element one by one from the array. So now let's save it. And if we execute it, it should work for all the patterns. So we have critical, fatal, error, and so on. Perfect. Now, optionally, just to make our output a little bit more readable, and many shell scripts or bash scripts actually have that, so let's just do it as a demonstration. We can actually add additional what's called decoration, output decoration, to just see the output much cleaner. So we could do something like this, for example. For each log file, just have a very clear visual separation between where each log file processing starts. So let's save it and execute. And now it's a little bit easier to detect where the next log file starts being processed. So that's the first one. That's the second one. So that's just optional, but you can always add this type of additional visual output for better readability. All right, so now going back to our actual use case, we have created this script that does the work for us much more efficiently, much faster. And we can execute this script every day to give us the output we need in just one command. Now let's say we want to extend the logic of the script further to do even more with the logs. First of all, let's say we want to save the analysis in a report file. So instead of having it just output it here on the terminal window, we want to keep it as a file. So we can send it around, share it with others, or keep it for later or whatever. So it's going to be in a report file that we can reference. So going back to our editor, we're going to see how easy that change is. So every time this script runs, we want to create a new file, and we can call it log analysis report. So let's create a variable that's going to hold the value of that file name. So let's call it report file. And let's say we want to create it also in a logs directory, and we're going to call this log analysis report txt. So it's just going to be the output, which we saw right here, just saved into a file. And now every output that we have here, so these echo commands, as well as these grep commands, all of these need to be saved into the file. And it's super easy. Starting from here, the first line, we're going to forward the output of the previous command to this report file. Like this. That's it. So this will create the file if it doesn't exist, and it will write the output of this command execution into the file. That's it for writing contents into a file. So I'm going to copy this and paste it on the next line for the next echo command. Now we need to do one slight change here, which is if we leave it like this, this will overwrite the previous contents every time we execute this command, right? So it will remove whatever was written before and we just overwrite with this output. But instead, we want to append every new output to the existing file content. And we can do that using double forward characters or greater than signs. So basically, this character writes or replaces the file contents and this appends to it. So now we can copy this, append, and just paste it after every output command. So this doesn't output anything because we are containing or capturing the output and saving into a variable, and then we are outputting the variable. So that's what gets saved here, and we can do that after every command output. Right here, we get the results of the grep. So we're forwarding that and appending into the file, and there you go. So this means that the output that we were seeing in the console will not be shown anymore in the terminal. So we will not get this here. It will be directed or forwarded into the file. However, we still want to display something as a result of command execution. So let's display it here. Let's do with new line. So we're going to add this escape flag. And let's say log analysis completed and report saved in, and let's reference the report file where we saved that information so that we can open it. So now let's save the changes and execute our command. Log analysis completed, report saved right here. So now I can actually copy this entire path, and if we actually, let's open it in Visual Studio Code again. And there you go. These are what our script commands executed and gave us as output. So now we can open it in a file editor to have a more nicer view. Instead of seeing it in the terminal window, we can do search here and so on. Great. Now let's do one final optimization to our logic, which is, let's say we run this script every day, and every day it writes the log analysis into this reports file, right? Great. Now let's say we want to make our work a little bit more efficient, and we want the code to do the analysis, and after saving the analysis in the report file, we want it to tell us right after execution if there is something that needs our attention. So for example, if it discovers that there are more than 10 critical errors or fatal errors in any of the log files, it should print out here, the report is saved, but there's something that needs your immediate attention. And based on that, we can decide to maybe check the report file later when we have time, or there is something urgent because we're getting lots of errors or issues in one of the programs, so we need to immediately react. And especially if the analysis report is really long, like we have tons of log files with a bunch of errors, we want some kind of intelligent analysis by the program itself to tell us, is there something urgent here or something that needs our immediate attention, or can I do the analysis later? And let's say the specific logic will be that we want to alert ourselves if any error pattern, no matter which one, has more than 10 occurrences in any of the log files. And we're going to alert us by explicitly printing it out here as a warning, for example. And that's what conditionals are for, which can help us program a logic that says if any of the error patterns occur more than 10 times, then alert with a message that something needs our attention. And that logic is actually very simple to implement because right here we are getting the number of whatever error pattern found in a specific log file, right? So we have that information here already. So what we're going to do is we're going to do command substitution as before. So we're going to take this command and save the result of its execution, which is the number of occurrences of a pattern, and save it into variable. So let's call this variable error count. And remember syntax for command substitution like this. And we can, as before, write this result, of course, in the report file. But in addition to that, we want to check whether this error count is more than 10. And if it is, then we are going to warn ourselves or alert ourselves, because that means something bad is happening. We have lots of errors. And that's where conditional comes in. We're going to say if, and we need square brackets. So if this error count that we got right here is greater than 10, then we're going to execute this logic. And we can do echo, and let's actually add like a warning icon. Action required. Too many errors. Too many of these pattern errors in log file, whatever log file that is. And let's add a new line here with escape. And once we're done with our if-else condition, we're gonna tell the program that it's finished with fi. It's an equivalent of done for the loops. So this is a conditional that does a simple check that says if error count is more than 10, then execute this logic. So now let's save this and go back to our terminal and let's execute it. And as you see, the log analysis was saved, but there is something that requires our attention. There are too many error type issues in system log. We can also call this issues so it doesn't repeat, but that basically gives us an additional evaluation of the scanned issues and a logic that tells us nothing crazy is happening. I just evaluated all the logs and saved the report, or there's something that needs your attention. And we can decide what that threshold should be. We can set it to 5, to 10, whatever for us means a lot of issues that needs our attention. So we can decide ourselves what that threshold of error should be. And that's basically our script that we took from this manual, repetitive command execution to automating logic in a pretty simple script that we can execute in a single command. It runs in milliseconds and gives us much more actionable result than those single commands. And the great thing is that once you start automating something and write a script like this, you can always expand it with additional use cases. You can add conditionals. You can add more complex calculations. What's even more important, you can share it with team and let others work on it and expand it. Just like application code, you can work collaboratively in team on automation code. Plus, it's also a natural documentation because it documents the processes that you're executing or workflows that you're executing as part of your job. And it fits into this everything as code concept that DevOps introduced. And as an engineer, this should make your job much enjoyable to write this type of logic and automation scripts to make things efficient than running the same set of commands every single day that doesn't actually teach you anything, and it's pretty boring. And this is just one of hundreds or thousands of use cases that you can actually do with automated shell scripts. Whether you are a software engineer, a systems admin, or a DevOps and cloud engineer, or even a QA, because there are definitely a lot of things that you are doing manually that can be automated with scripts. For example, you can write a script for local development environment setup. That means when someone new joins your project team, you can have a script that quickly sets up a developer's local machine with all the needed tools and configuration and test data, and with one command installs any required software versions, configures the environment variables if needed, clones any relevant Git repositories, creates test databases so that that new project member, that new developer in the team or engineer has everything ready in their local environment to get started. And that can actually save hours or maybe days of manual setup and troubleshooting, and also ensures the consistency that every developer has the same consistent environment. Or consider another example. You could write a script that scans server log directories daily, then compresses older logs and deletes the oldest ones based on space usage, because log files take up space, right? So you need to clean them up time to time. And it can have a logic that emails admins, whoever's responsible, when disk space runs low and the resources needed to be freed up, and maybe keep important error logs longer than routine logs. Again, this will help you save disk space automatically, or you can even configure it to automatically clean up the older logs to save disk space automatically without manual intervention and prevent servers from crashing because of that. And we're going to include some additional use cases that you can automate in the handout, because there are definitely a lot of them. And you can even use them to practice your shell scripting or bash scripting skills based on what you learned here even further. So I hope you learned a lot in this crash course. You now definitely have the fundamentals to build on top of it if you want to build out your shell scripting knowledge. And if this helped you, pay it forward and share it with one colleague who you think will also benefit from this knowledge. And as always, thanks for watching and see you in the next video.